Hello, it's me, Professor Albert, here again with Lesson 11. Let's learn some econ. So today we're going to talk about income and substitution effects and how these both necessarily follow anytime there's a change in prices. And we'll see this in the graphs. Also, we're going to talk about income and substitution effects as they relate to cost of living adjustments. So if we were in person, I would write on the board in big letters that the substitution effect refers to a change in quantity demanded when a goods price increases or decreases, holding other prices in consumer utility form constant. I would also write in the board in big letters the income effect is the change in quantity demanded when income changes, holding prices constant. Sadly, I don't have a big whiteboard on me, so write it in your notes. You're going to need this in a minute. So what do we know about income effects? That is, what can happen to sausage demand if your income goes up and sausage is one of your two items demanded? Think this one through, remember what happened last time, and draw me some different doodles. So should sausage demand go up, down, or do we not know? Next, ask yourself, well, what should happen if we focus on just a substitution effect? That is, what happens to sausage demand if the price goes up and we ignore all the weird income effect implications? That is, although we know sausage price going up will make us poorer, and this might cause our sausage demand to go up or down, if we just ignore that and think only on the substitution between sausage and the other good, should our demand for sausage go up or down? So let's look at some graphs first. On this left, we have our initial consumption bundle. Then we have a budget change. You'll note that we are slightly wealthier as our budget has expanded. It is headed outwards. Has our demand for sausage on the x-axis increased or decreased? It looks like it decreased. How is that possible? I'm richer. Shouldn't I be demanding more sausage? Well, it depends on the nature of the good. In this graph, I've drawn it such that sausage is an inferior good, and therefore, as income goes up, I want less of it. Over here, we have an alternate diagram. Again, income has increased, but look what's happened to our sausage demanded. On the x-axis, you'll see that we now demand a larger number of sausages. Therefore, this suggests sausage is a normal good. So, what happens to our demand for sausage as income increases? Depends. Depends on the nature of our demand for sausage. Here's a graph of what I think we would picture happening if there was a price change for sausage that was isolated. That is, imagine we started at some initial demand given by initial budget on some fixed indifference curve. Then picture that our price changed. We know the prices change between this line and this line because they have different slopes. However, you'll note that this new budget set is tangent to the same indifference curve we started on. This would be sort of a compensated price change. That is, although the price has changed, we've been given enough money so that we don't feel any poorer by it. And you'll note that if they make sausage more expensive, we know sausage is more expensive because this line is steeper downward sloping than this, so that means it's harder to buy things on the x-axis. So the price has gone up, and we are also given money such that we are not subject to any income effects. And you'll note that necessarily our demand went down. No matter how I draw my budget or my difference curves, if I rotate those curves such that they remain tangent to the same indifference curves, as they get steeper, I must be demanding less and less sausage. So, in short, income effects are simple-ish, but still can be a little complicated, right? So as our income goes up, we might demand more, we might demand less. Substitution effects, however, although less clear, are very consistent. If the demand for sausage is being looked at and the price of sausage has gone up, well, the substitution effect must be negative. That is, ignoring any income effects, any price increase must make us at least weakly interested in consuming less of some product. So let's do a price change, and let's see exactly how we can find the income substitution effects from just this. So first off, Let's imagine we consume CDs and DVDs, and we start at some initial bundle, call it E1. Copy a diagram like this, and then tell me, well, how do I change my diagram to show an increase in the price of CDs? Well, if CDs are more expensive, does that change the number of DVDs I consume if I consume no CDs? I think the answer is no, right? I can still consume 15 DVDs, so we'll keep that point there. Next, if the price of CDs increases, should that increase or decrease the maximal quantity of CDs I can consume if I'm only consuming CDs? Well, that should be less. So connecting two dots like that, we should get a slightly steeper downward sloping line. Next, we might ask, well, an increase in the price of CDs changes my consumption from E1 to E2, and now I'm certainly using less CDs per year. We know that some of this decrease is due to a substitution effect, right? We said anytime we increase price, we will demand less of a good due to substituting into the other good. However, we are also poorer, so some of this change is almost certainly due to an income effect. Can we tell what portion of this 12 minus 6 change in CDs is due to substitution effect versus income effect? As drawn, I don't think so. So let's try to draw some additional lines. So take a minute and draw this, and then draw a new imaginary budget line that will show us the substitution effect, i.e. the effect due just to a change in price. This new imaginary budget line will be compensated like we did a few slides back. That is, the new prices should be obeyed. That is, the line should be parallel to this one. However, we need to draw a line parallel to this new one such that we are indifferent to our original bundle. That is, this slope, but tangent to this line. How can we draw a line like that? Give it a shot. When I did it, through the powers of clip art, I end up at this point E star. You'll note that this line, this imaginary budget slope, is equal to the slope of L2. So our price has increased, we've gone from L1 to L2. If we are then compensated to make a compensated budget, we would be at the same slope of this, but indifferent to our original indifference curve. And we know we're indifferent because E star, the tangency between L star and our indifference curves, well, it's the same indifference curve we had at E1. So let's think about these regions. What changes between E star and E2? Is that a change in our relative wealth or in the relative price of CDs and DVDs? Well, that's clearly just a change in our income, right? This point is given by this line, which is the same slope as this line. Therefore, this must be our income effect. Next, compare E star and E1. Has our relative wealth feeling changed between E star and E1? No. We're consuming on the same indifference curves. We're just as happy, we feel just as wealthy. Therefore, since our income has not changed, what effect must be the remaining 3 units? Clearly substitution. So, anytime we have a price change, you'll observe we will move between 2 points, such as E1 and E2. We can decompose that total change into an income and substitution effect by first drawing the compensated budget line, which is defined as being parallel to the new budget line, but also indifferent to our original bundle. The difference between our new and compensated bundles will be the income effect, and the difference between our original and compensated will be a substitution effect. And by that, we can decompose the whole change in the quantity of, for instance, CDs demanded. So let's do a couple practice ones to see how this can get wacky. Here we have perfect complements, one of our usual suspects. Pretend we've changed from this original price level to this price level. Please find for me the income effect and the substitution effect. Well, you'll note that the original utility level is associated with bundle E1. We have then moved from this price line to one that is steeper, to some lower utility level associated with bundle E2. if I were to make a parallel line to this, you'll note that it suggests a new optimal bundle that's at E star. So, what do we call the difference between E2 and E1 on the x-axis? Is that the income effect or substitution effect? Well, from E2 to E1, from E2 to E star, I've only changed my income, right? On this line, they're on the same slope, this is income. Next, if I were to compare the difference between E1 and E star, I would find the substitution effect. However, that's zero area. E1 and E star are at the same point, so there's zero substitution. Why is that? Why is there no substitution effect in this diagram? Well, we have perfect complements. These goods have no substitutability. We need to consume them at a fixed ratio, so an increase in price just makes us poorer. We cannot substitute ice cream for pie or vice versa. So that's why looking for income and substitution effects with perfect complements is a little wacky. Let's try another one. Here we have perfect complements. Suppose we start with x1 plus x2 as our utility. The prices are given as being the same, i.e. they're both cost us 1. And let's say that the price of good 2 doubles, i.e. we head into a good 2 is twice as expensive. Find for me the income effect and substitution effect. This one's kind of wacky too. So if we start at our original consumption possibility for NTRI or budget, we can consume anywhere. We can consume here. We can consume here. Let's make this one interesting, and let's just say that we, by choice, chose bundle A. Well, because the price has gone up even a little for Coke, we're then going to snap to this point because Pepsi is relatively cheaper. So it could be that from here to here, we've entirely substituted out. Now, are we any worse off? You'll note that A and B are associated with the same original indifference curve, so we don't need to be compensated, i.e. there is no income effect. Alternately, we could have just stayed here. We could have said that bundle A equals bundle B, and there's no income or substitution effect. In this way, because substitutes causes us to consume often at the corners, income and substitution effects can be a little wacky. Here's another weird one. Look at this diagram where we have increased our budget. That is, rice bags have become a lot cheaper. We've moved from this pale blue line to this dark blue line. Find for me the price and income effects associated with this. That is, the substitution and income effects associated with this. Well, you'll note if I draw a parallel line to the dark blue line, it's going to intersect my original utility indifference curves around here. So that's fine. Our compensated bundle is E star. So our substitution effects from E1 to E star, our income effects from E star to E2. How is this different? What's different about this from the other ones we've seen? Well, you'll note, although rice has gotten cheaper moving from E1 to E2, we're actually consuming less rice. And that's weird, right? The income effect is so strong that it has outpowered the substitution effects. So even though rice is relatively cheaper than all other goods, we're now consuming less of it. This was what we would call in the field a quote-unquote Giffen good. There is not much evidence that Giffen goods really exist, but they are at least theoretically kind of interesting. If you look on the internet, you'll find the only good story that someone has found good, strong evidence of a Giffen good involved training rats to take prices and offering them root beer and quinine water. You can tell just from the nature of that story, economists had to dig pretty deep. So if we were to do this mathematically, which I might do on an exam, we would refer to what's called the Slutsky equation. In short, a Russian mathematician with the last name Slutsky found that the total effect, i.e. the price elasticity of uncompensated demand, must be equal to the price elasticity of our compensated demand plus the share of the budget spent on the original good times the income elasticity of demand. So although we just did all of these using diagrams, we actually could math out the the good level differences between all these different points. And the way we do that is just solve for the elasticities associated with each of these, which is something you can do, right? We've solved for elasticities bunches of times. So let's try a practice exercise. Let the price of good 1 be 2, price of good 1 be 1, price of good 2 be 2, and your budget be 9. Then suppose that P1 changes to P1 equals 2. We have 3 different utility functions. One is your utility is the min of x1 and 2x2. Second is your utility is the sum of x1 and 2x2. And the third is your utility is the product of x1 square root and x2 square rooted. Find the changes in demand due to each of these. And let me know how it went. Lastly, we should talk quickly about an incidence where these compensated budgets are a real thing, something that we'll encounter in the real world. And that's exactly something you'll go through frequently as a military officer. So you might not know this, but a very interesting process occurs when you get a quote-unquote cost of living adjustment. So let's suppose after graduating you begin as a casual lieutenant in the Springs. And then you're sent to Los Angeles for grad school overtraining. How and what prices do you think change between LA and Coast Spring? Well, certain things are probably more expensive in LA. For instance, real estate's really expensive in LA. Other things are really expensive in Colorado Springs. Let's say that maybe vehicles are more expensive in the Springs. What the government will do is they will give you enough money so that you can consume whatever bundle you were originally consuming in the Springs at your new base in LA. Okay, so let's try one for real. Let's suppose you started on this light blue line, and therefore you have optimized to find yourself at some bundle, call it E1. Let's say then that your new base has higher price levels in all things, like LA. And then you're trying to optimize subject to this much more expensive area with a slightly different slope, i.e. the red line. Can you maintain the same standard of living on the red line as you originally did on this light blue line? The answer is no, right? We are much poorer on this red line because it is so far inwards. However, we also need to keep in mind that the types of things we consume on the red line are different. You'll note food is comparatively cheaper on the red line, and units of clothing are comparatively more expensive. So one, price levels overall look to be a little bit less, a little bit higher, but also the types of goods that are cheap and not has switched. So what the government will do is they'll say, oh, you've started consuming bundle E1, given by the light blue line and original indifference curve. We've sent you somewhere with much higher prices. They will then give you money such that you can consume the same bundle. You'll note in order to consume the same bundle, they'd have to shift you all the way to this dark blue line. My question is, if they did shift you to the dark blue line, would you consume E1 anymore? No. In fact, because the price levels are different at the new location, even though you could consume the original bundle, you can also consume this better bundle with more of the cheap good, called E2. And how do we know it's better? Well, it's associated with an indifference curve that's north and east of E1. So, in short, if your income increases due to a price change, you're going to come out better than if no change happened, right? Intuitively, you're going to start consuming more of the good that's relatively cheaper at the new location, even if both goods in absolute terms are strictly more expensive. So these cost of living adjustments are actually really good. You could consume your original bundle because the government gives you enough money to afford it, but you don't have to, right? You can consume this new bundle, taking advantage of whatever's cheap where you are. That's all the time we have for today. Catch you next time. Bye.